aktarıyorsunuz. Yes, now it is the turn for Noor Ahmed Yaqubi. He is going to deliver his speech on analysis of 2018 Dikmen flood and remedial measures. Yes, welcome.
Hello, my name is Noor Ahmad Yaqubi. I'm a master's student in Mid-2 NCC in Northern Campus. And we are working on the analysis of 2018 Dikmen flood remediation and modeling. In the outline of this presentation, I will briefly talk about why it's important that we need to develop flood assessment maps. Secondly, how we can develop, what's necessary for us in the development of those kind of maps. This will be shortly overseen. And lastly, an ongoing project that we have with Dr. Berto Hoja and Dr. Hassan Hoja. We are working on the modeling of 2018 flood maps and seeing our coming different flood scenarios. And then I'll go briefly on what's possible and what things can be done to prevent or protect those areas that are possibly under the flood risk. So first of all, why it's important to develop flood maps. So flood hazard maps usually helps us identify the areas that are at risks of flooding. This is obviously known fact. Consequently, we can improve flood risk management and disaster preparedness based on the 100 years or 50 years or 500 years flood event scenarios. Preparedness for the hazards includes the changes in land use planning, implementation of specific flood-proofing measures, creation of emergency responses. Based on these risk maps that we create, we can create certain emergency response plans for those specific areas. For example, if a flood happens, we will probably know that which areas are at the higher risk, so the emergency aids or helps can go there faster. And also, flood maps can encourage people living and working in flood-prone areas to find out more about the local flood risks and to take appropriate measures. So in order for us to develop flood maps, as you can see in the left side, there is this Dikmen area that I'm working on it. The flood that's coming is coming from this mountainside to the city area there. So we are trying to develop a flood maps to see which areas are under risks. So for that, we need a certain data sets. First of all, it's topographic, also known in our part of the world, digital elevation models, or DEM. So according to the EU guidelines, the DEMs, digital elevation models that are used for this, is usually, they should be minimum 10 meter in cell sizes. Like in each 10 meters, we have to have the elevation. But 5 meters cell size data are preferred. So in order to generate those kind of maps, because these areas are big, how can we generate those kind of DEMs? We can use LiDAR, light detection and ranging, which is unfortunately unavailable for this specific area of Dikmen. In generally, as I guess, it's not available in whole northern Cyprus. We have Srtm Shuttle radar topographic missions. This is available for this area, but it has a resolution of 30 meters to 30 meters. So we cannot use this for the flood modeling. We can use this for the hydrologic modeling, but not for the flood modeling. And the other way is conventional surveying and contour maps. Conventional surveying and contour maps, it's available, it can be done, but it's a kind of expensive measures. It takes a lot of efforts and times to develop those maps. And also, a relatively new technology, aerial photographic techniques or use of drones to measure the lands and generate the contour maps. Other important data set that we need is a historical data, like what kind of flood that happened before, as Hassan Hoja expressed. We have to have the historical data. Why we need historical data are needed to raise awareness as well as for the calibration of flood modelings. So, and calibration to past historic event is the most effective methods for us to make sure that the model that we develop is performing well. Historical data that can be used in the flood modeling is flood maps, flood extent maps, like which area was covered under the floods, with water level records. For this case specific of Dikmen, we have only the flood extent maps. The others are kindly missing. Water level records in river and channel, velocity records, flood marks. Flood marks can be on the trees, on the houses, on the roads sometimes, but if the measurements are taken like immediately after the flood. Aerial and satellite photos, and pictures of floods. This kind of pictures would be very useful in the calibration in developing model. Other important data is land use and related data, like for what kind of area we are developing our maps. For example, it's important to know which area of our interest has floodplain structures, what kind of soil it is it rough, what kind of mining roughness should be put as input into our models, what kind of rainfall we are experiencing, and such, which areas are residential, which areas are non-residential, agriculture, and etc. Hydrological models. Hydrological models, I mean like hydrological data, like such as rainfall, because most of these floods are due to the rainfalls, not the normal stream of the rivers. So we use hydrological models to determine hydrological parameters. What kind of hydrological parameters? Flow hydrographs of flood waves from inputs. Our inputs are usually precipitation data or rainfall data. Hydrological parameters that we get as flow hydrographs is put as input in our hydraulic models to give us the flood model. The software that I used for the development of that flood map is HMS. So in order to develop a flood map, the main software that I used is HECRAS 6.0. So this HECRAS can be described, the flood map usually can be described in 1D, 2D, or 1D, 2D as a combination of these two. Wide range of tools can be used for the development of flood mic. It's available for 1D or 2D. HECRAS, 1D, 2D, Flow 2D. And results outputs that we get from this is very important. What kind of result we get? We get flood extent, flood depth, flow velocity, water surface elevation, and etc. So this flow chart that I've prepared can show briefly like what kind of steps we take. We need to have our topographic data. We develop that using ArcGIS. Then we need to also have a surface roughness manning layers that we call it. And also we need to have our hydrological model for the flow hydrograph. We put this together in a hydraulic model, and then we develop the initial model. Once we develop the initial model, we match the results with our historical data, as I said before. If it's a rainfall, if it's a flood extent, once we match, if it's matching the flood maps, then we say that this flood map for that certain period of time is generated. And using that flood maps as a base, we can develop different scenarios. So these two videos shows the flood extent that happened on 2018 on Dikmen. This one is the flow depth, and the maximum is 1 meter, so it's coming from these mountain areas. We didn't consider the influence of the floods from the city, since it's an ongoing study and various inputs in different scenarios can influence. For example, the use of, we only consider this as an open channel, but there is some culverts, bridges that are probably filled, or their openings are not as we considered here. So with the inputs of those data, we can improve our models to a better sense. This is the calibration that I was talking about. Like, for example, in 2018, the observed map, which is shown in the pink, this map was provided to us by the municipality and urban planning areas. It can be shown that we are actually, the model that we developed using the computer and HECRAS model is actually literally not 100% matching, but we are very close to getting the actual flood map areas. But with the development and some adding and other developments, we can actually find the most accurate maps, and based on that, we can generate the upcoming flood scenarios of 100 or 500s for very extreme events. Last, as Asanoja told, I don't need to go into details of that, but for the flood protection and prevention measures, there is two kinds of measures can be done: structural measures and non-structural measures. It's a general sense. So for the structural measures, we can build or construct dams, reservoirs, channels, levees, and other kind of diverting measures to prevent the water to enter our urban area. Or we can flood-proof our existing structures that we have if we don't have the availability of building reservoirs and dams. But this can be done on the new structures. New buildings can be done. How can we implement the flood protection measures? New buildings that are being developed, we can be proposed to them that they should increase the level of their entry levels to above the flood level. We can recommend the installation of flood protective walls, waterproof closures, and bridges. That also needs to be considered because the bridges and their openings can be closed as the debris and this kind of other things that the flood brings with it. So it can be closed. We have to consider in the design of the bridges. And non-structural measures, land use planning at local or municipal level can be useful in reducing the future flood damages. So thank you for listening.
Thanks a lot, our colleague Noor.